All right. So let's go ahead and start with a new section today. Last time we talked about Venn diagram. Okay. Any question on that? All right. So let's go ahead and talk today about or introduce in today what we mean by probability. Uh, in probability, or basically probability, is studying the outcomes or experiments that we do to predict something. Yeah. Right? In general, we have some experiments we do randomly, are done randomly, and in random experiment, it's hard to predict what kind of outcome you're going to have. There are a few definitions. Let's go ahead and uh, look look them up. The experiment you do, is called a trial. So, for example, whatever experiment I'm doing on whatever things I'm interested in, this is normally called a trial. Yes? The result or possible result, let me put it this way, possible results are called outcome. Okay? So we say these are the outcomes of the experiment. Yeah? And another definition, all possible outcomes, all possible outcomes are the sample space. All possible outcomes are the sample space. Event could either be a single outcome or it could be several outcomes. Yes? We can say an event with one outcome, we go say a single outcome event. Yes? And an event that contains several outcomes, we call it multi-outcomes event. Okay. Let's go ahead and explain all of these in an example. Suppose we roll a die. We have a six-sided die. In a six-sided die, usually has numbers from 1 to 6. Yes. If the trial or the experiment I'm doing is rolling the die, right? I'm going to take a die, I'm going to roll. Yes. What are the possible outcomes I could get? You could get all the numbers on the die itself. So you can roll it, and when it stops, it could show 1, 2, 3, 4, 5, or 6. We don't know. Yeah. So the sample space normally denoted by S is the set of the number 1, 2, 3, 4, 5, 6. Okay. The outcome would be whatever number shows up. Yeah. So if I roll the die and then the outcome was, or it stops on 1, then the outcome for that trial is 1. You could roll it and you can get a 6, and the outcome for that particular experiment is 6. Yeah. The event is what I wanted to happen. Yeah? Suppose you're playing a game with a die, and then If you get a 2, you win. Yes? So your event will be consist of one number, which is 2. Yeah? But we could have more than one number for the event. We could have, say, for instance, if you get an odd number, you win. Then your event would be all the odd numbers. In this case, it will be 1, 3, or 5. Yes? Sometimes the sample space is already given. Sometimes the sample space we need to deduce it from the given information. Yeah? So tossing if you have a coin and you toss a coin, how many outcomes you could have? 2 outcomes, yes? They could either be head or tail. Okay. If you have 2 coins, different, let's say a quarter and a dime or a nickel, what have you, right? And you threw them on the floor, what kind of outcome you could have? 2. In this case, every outcome consists of a pair, right? Because when you have 2 coins, you're going to see 2 things, yes? So what are the possible outcomes? Let's say you have the quarter and nickel, yes? The quarter could be head, yes? And a nickel could be head, correct? That's one outcome. The other outcome could be the quarter is head, but the nickel is the tail. That's another outcome you could have, correct? You could also have a tail for the quarter and a tail for, or a head for the nickel, yeah? And they could both be tails, yeah? So in this particular experiment, or in this particular trial, I have 1, 2, 3, 4 different outcomes I could have. So the sample space is, each outcome consists of, say, 2 letters. Yes? So these are my sample space. Each one of those is an outcome. The event is whatever you make a decision. Sometimes we make a poll, and then we can specify these polls as young man, middle-aged man, older man. Yes? In this case, for example, your outcome can be written as ordered pair. So, for instance, one outcome could be a middle-aged man. Now, notice it has an order pair to specify. First of all, it says a man, right? And what kind of man? It could also be a young woman. This is one outcome, yeah? So you could, whatever results or whatever poll you're doing, you're checking on that, yes? Another scenario, let's go ahead and take a scenario and let's write down the sample space for that scenario and work with that. Suppose a family, let's just say a family, planning, if they live long enough, to have 3 kids. Yes? A family is planning to have 3 kids. And we want to write down a sample space. We want to write down a sample space that describe how those kids come. Yeah? So I'm going to make some kind of a tree to describe the scenarios one space at a time. Yeah? So the first kid they could have could be either a boy or a girl. Yes? So here's kid number one. Boy over here, girl. So after they have the first boy, then the second child could also be what? A boy and a girl. Yeah? So now we have a boy here or a girl here. So far so good. But if the first child was a girl, after that they could also have the second child could also be a boy or a girl. Yeah? So now this is child number two. To go to child number three, if the first child was a boy, the second child was a boy, then the third child could also be a boy or a girl. Yeah? And this also scenario would also give me a boy or a girl. But if the first child was a girl and then a boy, we could also have a boy and a girl over here. And we could also have a boy and a girl over here. So how do I describe the sample space? First scenario, the first is a boy, and a girl. Yeah? So I'm boy, sorry. So this is scenario number one. Scenario number two, you could have a boy, and a girl. Clear? So on number three, now instead of having boy, we don't have boy and a girl. So we can have boy, girls. Boy, or boy, girl. Girl, yes? In this scenario, we could have first is a girl, then two boys. First is a girl, then a boy, then a girl. And then we could have girl, and a boy, or all three of them are girls. Yes? So even though we're only looking at three kids, how many possible outcomes for those kids they could have? So we have 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. So my sample space is 8. Yeah? Let's say the event, they want 2 boys, 1 girl. Yes? How many elements or how many possibility we have for that scenario? So they want 2 boys, right? And a girl. This is one. Where you have 2 boys and a girl. Yes? How about this one? This is another one where they have 2 boys and a girl. This one, they have 2 boys and a girl. Yeah? Any other? Now, this event then consists of 3 outcomes. Yes? They could have a boy, and a girl, boy, girl, and boy, girl, boy, and boy. Yes? So these are explaining what the sample space. So to describe the sample space, we put it in a set notation. Yeah. Say this is your set, S is equal, set notation, and then we will describe, we will write all the possible outcomes separated by a comma. So be boy, 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 and then boy, boy, girl, and then so on until we're done with all the sample space. Yeah. The event itself has three possible outcomes, and these are boy, boy, girl, boy, girl, and a boy, or girl, boy, boy, and this is the event that they are aiming for if they want two boys and a girl. Okay? Any question on that? So how many outcomes we have where all kids are the same sex? They could all be what? Three boys, right? Or they could all be three girls. So this is a scenario that explains what different events could happen. Yeah? All right. We can have, oh, we can have set operation on an event. For instance, we can look, if we have two events, let's say event E, roll in an odd number, and we're looking at six-sided die, yeah? And let's say we have event F, says roll in a number less, say, than 4. So those are two events of rolling a die. Hmm? We chose two events. Event E is the set of all odd numbers in the die. And the set of all odd numbers would be 1, 3, 5. Okay? Event F would be a set of all numbers on the die that are less than 4. So in this case, E1, 2, and 3. Yeah. So now we can apply, we can use a set operation to combine these. What do we mean? For instance, if we're looking at E union F, in this case, we said E union F would be all the elements in E or in F or in both. Yeah? So we go ahead and say, let's start with the set E first. Let's write all the elements in set E. So that'll be 1, 3, 5. Yeah? And now we're going to go to set F and write all the elements in set F that I did not list. Yeah? So what would be the elements that I did not list? 2. Yes? So this is the union between those two sets. So what is the intersection between these two sets? Do I have an intersection? Intersection means do I have a common element between those sets. The common element is, if you can look at set E and F, you can see 1 is in both sets. We can also see 3 in both sets. So that's 1 and 3. Okay? What is E prime? E prime is all the elements on the die other than the ones in E. So that would be the set of, notice the die has 6 elements, 1, 2, 3, 4, 5, 6, yeah? 3 of them are in E. The leftover would be in E prime, the complement of E. And that would be 2, 4, and 6. So this is the complement of E, yeah? If I take another set, let's say, notice E is all the odd numbers, right? E complement are all the even numbers. Notice between those two sets, we do not have any intersection, yeah? So let's go ahead and we call these sets disjoint sets. Why? So disjoint set, disjoint sets are sets with no common elements. So if we say, for instance, E and F are disjoint, that means what? It means E intersection F equal the empty set. That means the intersection between E and F will be the empty set. So in this case, if I let F be the even numbers, if I let F be the even numbers, then we know E and F in this case, let me call it something else. E enter F in this case. So let's J equal the even numbers, right? Then we know E and J are disjoint. So we know those two sets are disjoint if they don't have, because E is the odd numbers, right? And J is are the even numbers. So therefore, they don't have a common element. So therefore, they are disjoint sets. Yeah? They have nothing to do with each other. Clear? Probability of an event. So everything that we do, a trial we do, we always say several possible outcomes. Yes? Each outcome has a certain probability of it happening. Yeah? So if I take a die or if I take a coin and I toss it, right, I could get either head or tail. Yeah? The outcome is not predicted until it happens. So therefore, there is possibility of getting head, right? There is a possibility of getting a tail. In either way, it's possible. So each outcome has a certain probability. Okay? So how do I determine the probability of an item? Yeah? So the probability of an event is the number of elements in the event itself. How many possible outcomes do I have in that event divided by the number of elements in the sample space? Yes? So when I look at the sample space, I see how many elements it has. I look at my event, I see how many elements it has, and then I divide the two. That is the probability of that event happening. Okay? So for instance, probability of rolling a 2 on a 6-sided die. So the probability of rolling a 2 on a 6-sided die is, first, the event I'm looking for is rolling a 2. Yeah? On the 6-sided die, how many 2s do I have? So we have 1, 2. So the number of elements in the event is 2. Let's call that event E. Yeah? How many numbers do I have? How many possible outcomes do I have on a 6-sided die? The sample space is 6 because it says we have 6 different outcomes. Yes? Oops. That's a 1. So now the probability of rolling a 2 equal 1 over 6. So 1 in 6 chances, yes, is we can roll a 2. Okay, probability 1/6. Okay. Now, what is the probability? Let's say F rolling an odd number. Let F be the event of rolling an odd number. Yeah? So what is the event of rolling an odd number? So first, we need to know how many odd numbers are there on the die. So the number of element in F equal to, well, F could either be 1, 3, or 5. So that's going to be 3. Yeah? Again, the number of sample space is equal to 6 because we have 6 different numbers. So the probability of E of F in this case is 3 over 6, which is equal to 1/2. Okay? So now we have this scenario. Yeah? Okay. What is the, notice, because the probability of an event, probability of the event is part of, the event is part of the sample space, and we always divide them by a sample space. So the probability of a certain event has to be greater or equal to 0, less than or equal to 1. It cannot be more than 1. How could it be 0? Let's say we roll in a die, a 6-sided die. What's the probability of getting a 7? 0. Yes? Probability of getting a 7 is 0. So it could be 0, but it couldn't be less than 0. So if your answer for a probability outcome came to be negative, you know it is wrong. Yeah? Or if it came to be more than 1, you know it's wrong. Why? Because the probability of all outcomes equal to 1. So for instance, let's say, what is the probability of rolling an odd or even number on a die? Yes? What's the probability of rolling an odd or even number on a die? Well, we know the die has either odd or even, right? So the number of outcome would be 6, yeah? And then the number of sample space will equal to 6. The probability would be equal 6 over 6 equal to 1. Yes? Now, if I do add the probability of all outcome in the sample space, I'm going to get 1. Yeah? If I add the probability of all outcomes in a sample space, we will get 1. For instance, if you have a coin and you toss it, probability of getting a head is, you got 1 head on the, hopefully, we're looking at fair coins, right? Is 1. And then the number of sample space, you can get either head or tail. So that's 1/2. Now the probability of getting a tail is also 1/2. So when I add all the probability together of that sample space, I end up with 1. Yes? On a die, we have each number has a possible outcome of 1 to 6. And there are 6 of them. If I add all 6, we end up with 6 over 6 would be 1 as well. Yeah? So the most you could ever get is 1. Clear? All right. Okay, it says, if a single card is drawn at random from a standard well-shuffled 52-card deck, find the probability of each of the given events. So we do have a 52-card playing card. It says, what is the probability of drawing an ace? So we have 52 card deck. Probability of drawing an X. That's probability of drawing an X. Well, first of all, before we decide, we need to know how many aces are there in a deck of cards. Everybody familiar with that? The number of aces, every deck of cards has 4 aces. Yes? So the number of possible aces is 4. Yeah? And therefore, the probability of getting an ace is 4 over 52, which is 1 over 13. Okay? Clear on that? Second question is, it says, drawing a face card. Drawing a face card. What's the probability of drawing a face card? Face cards are Jack, Queen, and King. Yes? So if I look at them, how many Jacks do I have? So we have 4 Jacks, 4 Queens, yes? And then 4 Kings. Yeah. So how many total face cards I have? 12. So then we do have the number of the event equal 12. And then the sample space, we have n of the sample space is equal 52. We have, because we have a 52 different cards, yes? And in this case, we have the probability of E, 12 divided by 52, and that's going to be 3 over 13. Yeah? Okay, the next question is, drawing a spade or a heart. So we have, how many different suits we have on the card? We have 4 different suits, right? And they are spade, heart, diamond, and clubs, right? And each one has, each suit is 13 cards from 1 to 10, and Jack, Queen, and King, right? So now we know the number in the spade is equal to 13, yeah? And then the number in heart equals 13, yes? And notice those two don't have any element in common. I mean, a card cannot be heart and a spade at the same time, yeah? So those two sets are disjoint sets. So therefore, the number in the event will be a total of 26, yeah? Then the probability is 26 over 52, which is 1/2. Okay? So now I did say those are disjoint sets. Yeah? What if they were not disjoint sets? So for instance, what's the probability of drawing, say, a spade or a queen? So probability of drawing a spade or a queen. So how do I determine that? Well, again, we're going to decide what each one has. We need to know how many cards are in the sample in the event. So how many cards in a spade we have? For the spade, we have 13, yes? How many queens do I have? 4. So how many total cards do we have in the event? Is it 17? So we do have 13 spade, right? We do have 4 queens, yes? There's something else we didn't pay attention to. Aren't we counted queen twice? Yeah, because when we count the spade 13, that has a queen in it, right? When I counted the queens 4, I also counted the queen in spade, right? So what do I have to do to adjust it? Subtract the one I added twice. Yes? Now, where does this one come from? This one is the intersection queen. There is a card that is a spade and a queen at the same time, right? And how many of those cards are there? Just one. Yeah? So now, when I look at this set, would be the element in set 1 plus the element in set 2, right? Minus the intersection between them. Yes? So, and now we can say, so this is going to equal to 16, and then the probability is 16 over 52. Now, if we look at the sets we were doing before, in the numbers, say we said the odd numbers, right? So E is the odd numbers, and then F is numbers less than, say, 4, yes? Now, what is rolling E or F? E or F means E union F. E or F means E union F. If I were to say E and F, that would be E intersection F. Yes? So we do have and, it is an intersection. When we have or, it is a union. Now take a look at this. E is 1, 3, 5. F is 1, 2, 3. Yeah? Then what is E union F? See, 1, 2, 3, 5. That's exactly what we're talking over here. Yes? So what is that? So the number of element in E union F is number of element in E plus number element in F minus number of element in E intersection F. So that is, how many elements in E? 3 plus. How many elements in F? 3 minus. What are the common elements? How many common elements do I have between F and E? We do have the 1 and 3 common, right? So minus 2, that's equal to 4. And that's it. Okay? So every time you're looking at a scenario or the other, you want to pay attention to the common element between the two. Because one thing could be in both scenarios. And in that, you have to take that into consideration when you're looking at the probability or the number of elements. Yeah? Okay, that's it for today. I'll see you guys on Wednesday.